Baby, take me back.
Hey, but Mr. Park, look at it this way. The bar of expectation is so low that if like even half of us get fives,
what the
you're
heck
gonna be
is
like,
this? Why do we have to do
jumping for joy.
I still look. We got 5 weeks to go. I expect everybody to get 5s.
Right.
If not, expect a visitor at your house sometime this summer.
Mr. Park.
No. You know what? When you're sleeping at night,
Put it in the mouth.
and then you're gonna be sleeping, and then you're gonna feel like, you know how sometimes you have that nightmare and then you can't move and you can't breathe. That's not a nightmare. That's me. That's me in your house choking you.
Mr. Park.
No, I don't want to hear excuses.
No, how surprised would you be if I got a 5?
I'm not gonna be surprised at all.
Why not?
I expect everyone to get a 5. It's not hard.
Ah.
What? You got that on camera? Can you show it, Mr. Brown?
Did I call?
Okay, where did we leave off yesterday? Where did we leave off? No, 11, right?
Yeah.
11. Okay, did you guys
No,
finish
we
it?
finished 11.
Oh yeah, we finished 11. So 12 then. Okay, let's continue. Did we at least try number 12? Do I have to walk around the room now?
Oh.
I didn't know how to do that.
Oh, good thing you came in for help this morning.
No one.
What about over there? Should I look over there?
Oh, Mr. Park, you're gonna retaliate.
I bet you Mrs. Yonashira's class did their homework.
They have multiple choices.
Well, that's okay. It doesn't matter because if you didn't do it, you better do it all tonight.
Are they on their free?
Sorry. Wait.
We have a lot of no, they're still learning stuff, Mr. Park.
No, they're not.
Yeah, they are.
Silence.
They are, I promise you.
Okay, f of x equals, okay, find the average rate of change. Now, every single year, students always get confused between average rate of change, average value, and what's the last one? Oh, the mean value theorem. Every single year they get confused with that. So that's what this problem is. You gotta make sure you know those 3 things. Now the first one says, find the average rate of change from x equal 1 to x equals 9. Now, everything you need to know is in your notes. I gave you 2 pages that has everything you need to know on the AP exam. It's like I boiled it down for you. I can't make it any simpler. Okay, what's the formula for average rate of change? What is it? F of B minus F of A all over B minus A. It is simply the slope of the line that connects the 2 points. That's what an average rate of change is. It's just a slope. So this is A, this is B, plug it in. So it's just f of 9 minus f of 1 all over 9 minus 1. And if this is the function, what is f of 9? 3. What is f of 1? 1 over 9 minus 1. And on the AP exam, that's full credit. You don't need to simplify that. But we're Iolani, 2 over 8. And what the heck, let's reduce it, 1/4. That is average rate of change. B, find the average value. Now what the heck is average value? There's a formula for that. 1 over b minus a, integral from a to b of f of x dx. This is the average value. So what it does is, for this problem, it's 1 over 9 minus 1, integral from 1 to 9 of f of x dx. Is it from 1 to 9? Yeah. Now what does this tell you before I compute this integral? The graph of f of x, this is root x, it's a base graph. That's another thing. Do we know our base graphs? I'm afraid you've been asked. From 1 to 9, average value gives you the average of all the y coordinates on that graph. Like what's the y coordinate right here? 1. What's the y coordinate right there? 3. And then you have an infinite number of points. What is the average of all the y coordinates on that graph? That would be this. That's what average value is. It gives you the average of all the y coordinates on the graph. So here we go. 1 over a, integral from 1 to 9 of root x dx. Do we know how to compute integrals? Yes, now the kinds of integrals you're going to get on the AP exam, either it's on the list or use substitution. That's the only kind they can give you. There will be no tabular. Take that out of your head already. If you're doing tabular on the AP exam, you're doing something wrong.
Really?
Yes, because there's no tabular.
Is tabular more advanced?
No, it's just that I think about 6 or 7 years ago they took it out.
So why are we still learning?
Because when you go to college next year, it's going to make it easier for you. Anyway, I still think tabular or integration by parts should be on the AP exam, but it's not. Anyway, what's the antiderivative of this? You make the power 1 bigger, put the reciprocal in the front, from 1 to 9. I like to factor out the constants, so you get 1/12, plug in the top number. What is 9 to the 3 halves? Minus 1 to the 3 halves. 1. So you get 26 over 12, and then you reduce that to 13 over 6. So that's like 1 and 1/6. So if you take the average of all of these y coordinates here, it's going to be 1 and 1/6. That kind of makes sense, right? Because there's way more points down here than up there. Yeah? Anyway, that's what average value is. And then the last one, the mean value theorem. This is, you know what you guys should be doing while we go over this? You guys should have your notes in front of you so you can see where on the page the thing is. So when it comes up again, you know exactly where to look. I guess that's not going to happen. What is the mean value theorem? Okay, let me review the mean value. Did anybody even look it up in the notes?
Yeah. If
You understand it?
From A to B.
Okay, I guarantee you, they're going to ask you this every time on the free response and the multiple choice. If you, first of all, the function has to be continuous and differentiable. It has to be smooth and continuous. Otherwise, the mean value theorem doesn't even apply. Okay? So this is y equal f of x. If you have a function that is continuous and differentiable from a to b, then there is at least one value of c somewhere between a and b, such that f prime of c is equal to f of b minus f of a all over b minus a. Now, maybe the reason why students get confused with these three things is all three of them have b minus a in it, yeah? Is that confusing for you? Yeah. Okay, let's break this down. What does this mean? F prime of c.
The derivative.
The derivative at c. So there is at least one value of c somewhere in between here, and the derivative tells you the slope. Where the slope is going to equal to this. Now, what the heck is this? That's the average rate of change. It's simply the slope that connects the two endpoints here. So if you draw a line that connects these two endpoints, there's at least one place somewhere in between here where the slope of the tangent line is going to have the same slope as that. That's the mean value theorem. The mean value theorem guarantees there's going to be at least one. Now sometimes on the AP exams, multiple choice, they give you a problem like this. Let's do that. Okay, they're going to ask you, for how many values of c does the mean value theorem 3 work? So here, draw this in. Okay? That's the line that has a certain slope. How many points on this graph is the slope of the tangent line the same as this slope? 1, 2, 3. So the answer would be 3. There's 3 values of c that satisfy the mean value theorem. But the mean value theorem guarantees there's going to be at least one. Okay, we got that down? So that's the difference between average rate of change, which is simply a slope, average value, which is the average of all the y coordinates of all these infinite number of points, and the mean value theorem. Does that clear it up? See now, after we go through all of these things, now what you guys got to do, hopefully you have all of these things in your tool belt. Is your tool belt heavy or light? And then you got to pull out the correct tool when you read the problem. And I think that's going to be the hard part for this class.
Oh, I don't even have a tool belt.
At least put it in your pocket.
Only pockets. Small pocket.
Okay, number 13.
Program it into your calculator.
You're only using the calculator on 40% of the test.
Like scribble it in the margins.
Oh my gosh. Okay, here we go. Now this problem here, guaranteed this is one of the free response problems. See, when you take the AP exam, at least you're going to know 4 of the 6 problems. Because it's pretty much the same every year, except they put a little twist in it. Okay, so here's -1, 1, 2, 3, 4, 5, 6, 7. So it looks like this. It's just these straight lines going like that. This is the graph of y equal f of x. This is 7 here. G of x, you guys remember doing problems like this? Remember in the book? We did many of these. I kept telling you, this is going to be on the AP exam. Okay, A. Compute G of -1, G of 1, G of 3, G of 5, G of 7. Now on the AP exam, each of these is going to be 1 point. It's either 0 or 1. There's no partial credit here. I don't think they're going to make you compute all of these, but this is just for practice. So. How the heck do you compute G of -1? Well, if this is G of x, how do you compute G of -1?
Plus -1.
You plug in -1. So if I plug in -1 there, you get this. But then, Mr. Park, the smaller number's on the top.
Sir, don't worry.
So, can you switch the limits?
Yes.
But you said put negative.
Yeah, that's one of the 5 properties of integrals you gotta know, and they're all on the notes. If you switch the limits, it negates the value. And then, if this is the graph of f, what does the integral from -1 to 1 tell you? The area between the graph and the x-axis. So here's -1 and 1. We need to compute this area right there. But that's simply a triangle.
1/2.
1/2 base times height, so 1/2 2 times 2.
2.
This is 2, by the way.
Oh.
It's 2, so what's the answer?
-2.
-2. Now, if you forget to put that negative sign, you just got yourself a 0 there. Because there's no partial credit. You either got -2 or you don't. Okay, next one is easy. If I plug in 1 for x there, you get the integral from 1 to 1 of f of t dt.
0.
And one of the properties of integrals, any integral from any number to itself is 0. Now it's easy. Okay, plug in 3 now. So you get the integral from 1 to 3 of f of t dt. And again, if this is the graph of f, what does the integral from 1 to 3 give you? The area.
2.
2. And again, if it's above the x-axis, it's positive. If it's below, negative, right? Integral from 1 to 5 of f of t dt. Okay, 5 goes here. So from 1 to 5, okay, we figured out this is 2, this is 2. What's this area?
1. -1.
1/2 2 times 1 is 1. But it's below the x-axis, so it's going to count negative. So what's the answer? 1. And then the last one is 7. Integral from 1 to 7 of f of t dt. So from 1 to 7, now we're going to compute this, and that's just a triangle 2. So from 1 to 7, what's that integral? 2 plus -1 plus 2 is 3. You guys get it? If it's above the x-axis, it counts positive. Below the x-axis, counts negative. Okay? Next, where does the graph of G have an absolute maximum? Now, how do you find maximums and minimums?
Make a number line.
For what though?
The slope.
The derivative. So what you need to do is you need to make a number line for G prime. They're not asking you what the maximum of this graph is. This is f. They're asking it for G. So the first thing you got to do is you got to take the derivative of G. Okay. When you have a function that's an integral, how do you find the derivative of it?
Fundamental theorem.
The fundamental theorem of calculus part 1. So what you do is you take this and you plug it in there and you get
F of x.
f of x. And then you times it, and this is the most important part that some of you still forget. You got to multiply it by the derivative of that,
1.
which is 1. Now, it's not going to be 1 all the time. In this problem, it's 1, but sometimes it could be 2.
7.
Or whatever, yeah, which might change the number line completely. So you got to make sure you multiply by the derivative of that. Oh, so the derivative of G is same as f. So when you make your number line for G, you're just making a number line for this graph that you have right here. That's the connection you need to make. So how do I make a number line for this graph? Where does it touch the x-axis?
-1.
You do 1, 3, and 5. And how do I fill it in? It's above the x-axis, below, and above. What do I need to write underneath to get full credit?
G
No.
prime.
No. If G prime is positive, that means
X.
G is increasing. If any function's derivative is positive, that means the original function is increasing. If you don't put the correct letter there, it's like your number line doesn't even exist, which means you have to write paragraphs, and I don't think you want to do that. G is decreasing. G is increasing. So the problem is asking from -1 to 7. Where are we now? Oh, where do you have an absolute maximum? Now look at your number line. There are two maximums. Where do the maximums occur? There's maximums at where? X equals, look at the number line. It goes up, down, and up. Where are the maximums? 3 and at the end point over here. 7. How do you figure out what's the absolute maximum? So which one has the bigger y coordinate? But we did it right here. Right? These are g of 3. So we already computed g of 3, which we figured out is 2. And g of 7, we already figured out is 3. Which one is bigger? 3 or 2? 3. So therefore, the absolute maximum occurs at x equals 7. See, this is the analysis they want you to do. They want you to gather all the maximum points, and they want you to pick the biggest one. That's what they want you to do. Yeah.
Do you have to write the part after that too?
Oh yeah. What is that part? Oh, there's a oh yeah. You're right. Oh, come on, is right. There's a maximum at x equals 3 because what did I tell you to write? Yesterday, were you here yesterday? G prime changes from
plus to minus.
positive to negative. Now there is also a maximum at x equals 7 because, now, why is there a maximum at that end point right there? How would you describe that mathematically? Why is this point a maximum point?
Because g prime increases in sums.
Yeah, but then according to like the way we're writing it here, because g prime
Changes.
is
Increasing.
positive
Above.
when
When it
x is less than 7. I guess that's not really mathematically correct. Is positive just before x equals 7. I guess that would be a good explanation.
You have to write that,
Yeah.
even if the problem is asking for something else.
Yeah, because remember the directions is going to say show all your work, and that encompasses the whole AP exam. Okay, how are we going to finish this thing? You guys are in trouble. Absolute minimum now. Now look at this number line. Where are the absolute minimums? I mean, where are the minimums? So there's a minimum at x equals 5 because why? Why is there a minimum right here?
Because g prime
G-
changes from minus.
There you go. See, you guys are getting it. That's all you gotta change it from negative to positive. Oh. And why is there a minimum at x equal -1? Which is an endpoint, right? Why is there? Because no, g prime is positive just after x equal -1. Okay, now they want you to compare these two minimums, g of -5 and g of -1, but we computed them already. So g of 5 is 1, g of -1 is -2. Which one is smaller? Negative. Now, if you compute these wrong, just use your wrong numbers here, and if you show that you're picking the smaller one, then you're going to get credit. They don't like to dock you more than once for the same error. So you're going to get a point off over here, but then you won't get taken off a point there. Okay, so the absolute min is at x equal -1. Oh my gosh, how are we going to finish this?
forward-facing dog.
Maybe we're going to have to hand this in at the end of the period tomorrow. Point of inflection. Now, how do you find points of inflection? Oh man. Can I erase this right here? That's otherwise I don't have room. Okay, how do you find points of inflection? You need to make a number line for the second derivative. Okay, now this graph right here is the first derivative of g. So the second derivative of g is the slope of this graph. So what we need to look for is where, first of all, where is the slope 0? Is there anywhere where the slope is 0?
Yes.
No. There's nowhere where the slope is 0. Secondly, you look at where the graph comes to a sharp point, because when you have a sharp point, the derivative doesn't exist, right? So where on this graph does it come to like a sharp point? 1 and 4, and that's it. So what kind of signs do I have here? If the graph is going uphill, what can you say about the slope? It's positive. If the graph is going downhill, what can you say about the slope? And if it's going uphill, positive. What do I write underneath to get full credit? If the second derivative is positive, that means G is concave up. G is concave down. See, this is why I put that problem on, so you can practice doing what you're supposed to. G is concave up. So tell me, there are points of inflection at where? Where are the points of inflection? 1 and 4. Because, what's the reason? G double prime changes sign. There you go. Holmes, are you paying attention?
Yeah,
Well, you're taking notes.
that's what you want to call it, sure.
That's, if I come over there and that's not it, you are banished. No, because if you're going to get a 1 on this test, you're going to get a 1 because you got it, not because I helped you. How can I help you get the lowest score possible?
Vanished from the kingdom, yeah.
Isn't the lowest score a 0?
No, the lowest score is a 1. There is no 0 on this test.
Well, it's better than a.
Okay, number 14. Given this, okay, now we're talking about the Riemann sums. Now, didn't somebody ask what's a Riemann sum? A Riemann sum is when you use rectangles to approximate an integral. That's what a Riemann sum is.
Riemann.
Named after the mathematician Georg Riemann.
What?
Never mind, you don't have to know his full name. Okay, so this integral, remember, integral tells you the area between the graph and the x-axis. So you got y equal x squared plus 1 from 0 to 6. Now, LRAM 3, what is that? What does the 3 mean? Divided into 3 equal parts, which of course means this is 4. And then what does the L stand for?
Left.
You use the left endpoint to cap off the rectangle. So basically, you just add up the area of those 3 rectangles. That's what it is. It's a Riemann sum, using rectangles to approximate the actual area. So what we need to know is we need to know the y-coordinates of each of these points. What is the y-coordinate here? 1. Just plug it in here. What about here? 5. What? 17. 37. Okay, so what's the area of the first rectangle? Base times height. The base is 2. In fact, is the base 2 for everyone? Why not factor it out then? Base. And what's the height of the first rectangle? 1 plus, then the next one. 5 plus. And then just leave your answer like that. Do not even attempt to add that up. Okay, next one. B. R RAM 6. We need another. Okay, let's just draw another picture. R RAM 6. That means we have to divide it into 6 equal parts. 1, 2, 3, 4. Oh, that's pretty good. 1, 2, 3, 4, 5, 6. Okay, and we're going to use the right endpoint to cap off the rectangle. Oh, are you paying attention for real? Oh. Well, take everything. Everything. Okay, what are the y-coordinates here? 1, what about this one? 2, 5, 10, 17, 26. Okay, so what's the area of the base of each rectangle is the same, it's 1, right? So factor it out. So what? 2 plus 5 plus 10 plus 17 plus 26 plus 37. And just leave your answer like that. C, M RAM 3. Okay, from 0 to 6, you break it up into 3 equal rectangles, except now we're going to use the midpoint to cap up the rectangle. 1, 3, 5. So what's the y coordinate right there for 1? What about this one right there? 10, and then what about right there? 26. So the base of each rectangle is 2, so factor it out, and then you get 2 plus 10 plus 26. This is no calculus involved. All you're doing is adding up areas of rectangles. Now D, trapezoidal rule with 3. So now we're going to break it up into 3 parts again. Except 0, 2, 4, 6. Or except we're going to connect the endpoints to make trapezoids. Now, do we remember the formula for the area of a trapezoid? Yeah, it's 1/2 the height times B1 plus B2. Now the height for each trapezoid is all the same, so 1/2 the height, you can factor out. And then all you gotta know is B1 plus B2, but I think we figured it out. Yeah, it's there. So what's the first one? What is B1 plus B2? 1 plus, don't even play with 5, just go 1 plus 5. And then 5 plus 17, and then 17 plus 37. And just leave your answer like that. Now, in problem E, is using LRAM an over or an underestimate explained? So here's LRAM. If I add these 3 rectangles, it's kind of dumb, right? Is it smaller or bigger than the actual area? It's smaller. Okay, underestimate, you get 1 point. If you want the other point, you have to explain why. What's the reason for it being an underestimate? Because, well, I don't know if it's defined as that. I guess they would accept that then. The function is increasing. See how it's going uphill? That's what makes it an underestimate. Because if it were coming downhill, like this, if it was decreasing, then if you make LRAM, look, LRAM would be an overestimate if it was decreasing. So what determines an over or underestimate is whether the function is increasing or decreasing. Okay, I don't think we're going to get to the end, so I guess tomorrow we're going to hand it in at the end of the period.
Support.
So we can discuss these other ones.
Support.
Huh?
How do you take the antiderivative of something that has 2 variables?
You don't.
Oh yeah, that's right. You told me.
You don't?
Yeah, I told you this.
Okay, we got 3 minutes. Let's do number 15. dy dx. Okay, this is guaranteed going to be one of the free response questions too. Draw a slope field. You guys remember drawing slope fields?
Oh, yeah.
For the last. Now, what they're not gonna. I don't think they're gonna give you 6 points. They probably give you like 4 points. At the points indicated, you have to draw in a slope field. So like here's the point 1, 1. If I plug in 1 for x and 1 for y, what do you get? You get 2. dy dx equals 2. dy dx means the slope, so the slope is 2. So just draw in a hash mark that has a slope of 2. And again, you have to know the difference between a slope of 1, which is 45 degrees, and anything bigger than that. That's how we grade it. 1 is a 45-degree angle, and 2 or 3, you really can't tell the difference, but it has to be steeper than 45 degrees. Okay, so what about this point? Here is the point 1, 2. So if I plug in 1 for x and 2 for y, what do you get?
1/2.
Half. It should look like that. It should be less than 45 degrees. And then basically you just fill it in. Okay, well let's just finish the problem. Can you guys do it? Here's the point 1, 0. So if I plug in 1, 0, I get undefined slope. What do I draw? Vertical. Undefined slope is vertical. In fact, Mr. Park, then shouldn't it be vertical here and here then? Because the y coordinate is 0? Yeah, okay, what about here? 0, 1. 0, 1. In fact, this is 0 and this is 0, right? Okay, what about here? Negative 1, 1. Negative 1, 1. Is negative 2. And this is negative 1, 2. Negative half. That's what your slope field should look like. It's just a field of slopes. That's all it is. Okay, we got 1 minute left. We're not going to finish, but okay, I want you to start. I'm just going to start you on it, and you're going to finish it, okay? dy dx equals this. How do you find, if you know the derivative, how do you find the original function? Well, if there were only x's here, you would just take the antiderivative. But if you have x's and y's, what do? We learned how to do this. You separate the variables. You put all the y's on the left with the dy, and put all the x's on the right with the dx. That's called separating the variables. That's one point right there. This is a free response. And then what's the next step? You integrate both sides. Then we know how to do this. 1/3 y cubed plus c equals x squared plus c. Now what do I do with the 2 plus c's? You mush them together into just 1 plus c. And how do I figure out what c is? You plug in the initial condition that's given. Okay, let's see if we can finish this problem. And I guess we finish the rest tomorrow. So, a lot of things to do if you don't want homework this weekend.